Bismillahirrahmanirrahim. Good afternoon, guys. Let's start to finish the chapter, the lecture number 6, part 2. Today's lecture is related with the ultrasound device, like I explained it before, how much kinds we have of ultrasound device. The important question is how ultrasound device does work. And I explained before the important contents of the ultrasound device. Let me use the slideshow and go deeply. At first, let's solve this question. How does an ultrasound work? Device during an ultrasound, the provider, the healthcare provider, passes a device called the probe. Like I said before, this part is the probe over an area of your body or inside a body opening such as a vagina or rectum. Here, like I explained before when I was talking about the most important contents of the ultrasound device, I said the screen, the probe, and PTZ was the important thing inside the probe, and by use alternate current, we can use it to make the BTZ vibrate, to can generate and emit the high frequency ultrasound waves. Okay, the provider applies a thin layer of gel like that. Why? We will solve this question at the next slide. To your skin so that the ultrasound waves are transmitted from the probe through the gel and into your body. That's mean high construction of the high frequency of ultrasound wave will go directly, deeply to the specific soft tissue, what you are working on or what you want to test. But why the provider use the gel while using the ultrasound device? Here, because the gel at this process helps, has important act, helps our bodies to absorb more as can possible ultrasound waves. The probe converts the electrical current, like I said before, it works on the alternating current into high frequency sound waves, like I said before, by the PTZ inside the probe, by turn on the current, the PTZ starts to generate and transmit ultrasound device, high frequency ultrasound device, by that and send the waves into your body's tissue. After that, come back again to the probe to convert the waves into electrical signals. And I used image at the previous lecture by using two arrows, one in, one out, second was in, to explain these few statements. A computer then converts the pattern of the electrical signals into images or videos, which are displayed on a computer screen like here. How much kinds we have of ultrasound device? We have A and B ultrasound device, more than another two kinds, more than this one. Here, let's start from A ultrasound scan. That's mean Amplitude A scan. It is an ultrasound device for diagnostic testing. Like here, the specialist works This device can determine the length of the eye. Wow. And can be useful in diagnosing common sight disorders. To resort to, let's say, to find out some disorders related with your eyes, to can know it, to can find out these disorders, the A scan ultrasound device will be the good choice. A scan are also extremely beneficial in contract surgeries as they enable on the ophthalmologist to determine the power of the intraocular lens needed for the artificial implant. Here it's important by working on this field, artificial implant, the A-scan ultrasound device is good choice to dealing with situations like this. And now let's talk about the B brightness scan biometry, ultrasonography. We can say ultrasonography. It is another method used for ocular assessment by ultrasound. In B-scan ultrasonography, an oscillating sound beam is emitted. An oscillating sound beam is emitted, passing through the eye and imaging a slice of tissue, the echoes of which are represented, like I explained before, as a multitude of dots that together form an image on the screen. That's mean, let's say we have incident waves and reflected waves. From the reflected waves, these reflected waves can float to us the specific tissues figure. Okay, by use this technique, the researchers could plot helpful image at the pregnancy, at another situations like that. This the mind rule the researchers are used. This is the screen here. It's a smaller than we can say a scan, little bit. Its contents are easier, a laptop and the prop, and by use the same laptop screen, we can display this plot. Okay. Here, let's take specific idea about the brightness B-scan biometry, how we can use it. B-scan can be performed by put the prop, this is the prop, on your eyes over the eyelid, with coupling jelly. Here some symmetry, the same technique. When I explained the ultrasound device, I said you will use some gel to make your body absorb as possible ultrasound waves. Here, the same idea we can say, because here we're using a coupling jelly with the same target. It's important comparison between A scan and B scan. Here, it's as homework to my students. But here I solved it at A scan, amplitude modulation scan, brightness modulation scan, but at B. Its frequency is 8 megahertz. At B, it's small. It's 10 megahertz. A scan, it's one dimension. B scan is two dimension. emits unfocused beam, but at B-scan emits focused beam. The situation is different. Provide quantitatively information, provide topographic information. The situation is different. It's a basis of ocular biometry, but here at B-scan allows real-time evaluation of any ocular pathology. Here at the last of this lecture, let's talk about Doppler effect before talking about the Doppler scanning device. What is the Doppler effect in physics? After that, we will do our link with your medical field. Doppler effect in physics is the change. What does mean change? Increase or decrease, okay? In the frequency of light or sound or waves or another. From what to what? We have observer and we have source. As the source and observer move toward or away from each other. That means at Doppler effect, I have three important contents. First one is observer. Second one is the source. Third thing is the distance between them. This distance is decreasing between them or increasing. That will mean a huge difference. Here, like we are looking, the source, let's say it's ambulance or fire truck, doesn't matter, with some sound. Here we have observer at the right, at the left we have another observer. What's the difference between them? Actually here the sound power, let's say, will increase. Why? Because the distance between the source and observer are decreasing. What that mean? That mean reverse relation between the source's distance and the observer. By decreasing the distance, the sound power will decrease. Here the situation is different. Why? Because the distance between the source and the observer is decreasing. By that, the sound power will increase. Like I said before, it's a reverse relation. Waves emitted by a source traveling towards an observer, like here, towards an observer, that means I'm talking about the situation, get compressed, that means shorter. When it's compressed or the waves be shorter, that means the sound power will be more. Or traveling away, like the situation from an observer gets longer. What does mean? That means the waves will be like that. By that, the sound power will decreasing. Here, an example, the ambulance siren or fire truck siren. The ambulance or fire truck and siren, and there are many more. Here is the source, and we have observer at the right and at the left. The same situation with all of these. Here the sound power will increase, here will decrease according to the distance between the observer and the ambulance. Now, after we take enough information about Doppler effect in physics field, now let's take a look the Doppler effect in medicine. How we can use this device, how this device works. The Doppler effect can be used to measure what? Wow, to measure the direction and the speed. To what? of blood flow in arteries and veins. By that, it is an effective tool to diagnosis of vascular problem. Let's take a simple look to this image. Here, I have two arrows. First one is incident wave sound and reflected wave sound. First one, the incident at the specific blood flow, blood cell. After that, we have the reflected sound wave. We'll take it the receiver part. By that, we can measure the power, the speed, and the direction of the blood cell. Okay? In arteries and veins. By that, it is an effective tool in diagnosis of vascular problem. Additionally, it's used in the echocardiograms and medical ultrasonography. This technique, it's used in all of these previous. Okay? Here at the last slide, let's talk about the benefits and risks of this Doppler effect in medicine, or Doppler effect, or Doppler scanning device. Benefits are huge, more than one. Let's take about the most common benefits. Most ultrasound scanning is painless. Why? Because we don't use any needles or injections. Ultrasound imaging doesn't use any ionizing radiation. Ionizing radiation. That means it's more safety than X-ray. Ultrasound scanning gives a clear picture of soft tissue. Ultrasound is preferred imaging modality for the diagnosis and observing of pregnant women on their unborn babies. Actually, we depended on these ultrasound devices, maybe 2,900%, specifically with the pregnant and unborn babies, from the first small cell and until before coming. Ultrasound provides real-time imaging. That means not just picture. Risk sound waves can increase body temperature only when using it for a long time. That means not a real risk like the radiation, like injuries, like blooding. That's it. Our lecture today was easy. Thank you about your watching, your listening. Have a good day and see you at the next lecture.